Section 10.6 is on being able to classify conics and rewrite our equations in either form, whether it be standard form or conic form. Just a quick review. Conics are curves formed by the intersection of the plane of our double napped cones. We have our circle when our plane cuts parallel to the base. We have an ellipse when it cuts other than parallel to the base. We have a hyperbola when the double napped cone is perpendicular to the base, and we have a parabola when it is parallel to the surface of the cone. And again, remember our standard forms of our conic equations. Parabolas are basically x equals 1 over 4p y squared, or y equals 1 over 4p x squared. Our circles are x minus h squared plus y minus k squared equals r squared. Our ellipses are x squared plus y squared over a squared b squared equals 1. And our hyperbolas are x squared over a squared minus y squared over b squared equals 1. So remembering that, when we are going to classify a conic, we must look at what our equations start to look like. So a circle is basically an x squared y squared equation with coefficients that are equal. So if the number in front of x squared and y squared are the same, and we are adding our equations, then we have a circle. To notice what we have with an ellipse, it is still an x squared plus y squared equation, but there our coefficients are not equal. They would be different. Still the adding of our coefficients. With a hyperbola, it is x squared minus y squared, or y squared minus x squared. So when we have the minus, we should have a hyperbola. And for a parabola, it is either x equals y squared or y equals x squared. There's only one square. All the rest of these have two squares. So knowing that, we should be able to recognize whether a conic is a circle, an ellipse, a hyperbola, or a parabola just by what is done to the squares. So these directions say classify the conic and then write the equation in standard form. So this first conic, we see we have 2x squared plus y squared. X squared plus y squareds are either circles or ellipses. And this one would be an ellipse, since the coefficients are different. So now I must write it in elliptical form. So I'm going to put my x's together. So that is 2x squared. And then put my y's together. Y squared plus 8y. And then I'm going to move my 6 to the other side. So that would be equals negative 6. So this is all, x squared is already a perfect square. My y squared, I'm going to need to complete my square to make it a perfect square. So this is 2x squared plus y squared plus 8y. I'm just going to write this up here. Plus what will equals negative 6 plus what? Well, remember, to complete the square, you take half of 8, which is 4, and square it. So 4 squared is 16, so I add 16 to both sides. So this then is the square y plus 4 quantity squared equals 10. So to be an ellipse, it must equal 1, so I must divide everything by 10. So I have x squared over 5 plus y plus 4 squared over 10 equals 1. And I now have it in elliptical form. My next conic, I see 4x squared minus y squared. So there's one negative between my squares, so this must be a hyperbola. So now I must write it in hyperbolic form. So I'm going to put my x's together, 4x squared minus 16x, and then put my y's together, minus y squared minus 4y, and then I'm going to add this 4 to the other side. This time I need to complete two squares. So I'm going to factor out the 4, and that would give me x squared minus 4x plus something to make my square. Factor out the negative 1, and I would get y squared plus 4y plus something to equal that square. And I am adding two values to this side. So if I complete my square, half of negative 4 is negative 2, squared is a 4. So on this side, I have this 4 I factored out, times this 4 I added in. So this is a 4 times 4 that I must put on this side to keep the equivalency. On this one, half of my 4 is 2. 2 squared is a 4. But I factored out a negative 1, so this is a negative 1 times 4 on this side. So this is 4. That square is an x minus 2 squared minus 1 times y plus 2 squared should equal, let's see, 4 times 4 is a 16. Negative 1 times 4 is a negative 4. So the 4 minus 4 is 0, so it equals 16. Again, my hyperbolas must equal 1, so now I must divide each of these by 16. And I get x squared, x minus 2 squared over 4 minus y plus 2 squared over 16 equals 1. And then I have my true hyperbolic form. All right, on this next one, I see I have 2x squared plus 2y squared. So this one must be a circle. So I'm going to put my x's together, 2x squared minus 12x, put my y's together, 2y squared plus 4y, and move my 2 to the other side. These are not perfect squares, so I'm going to have to factor the 2 out of this x's. So I get x squared minus 6x plus something to make that a perfect square. Factor a 2 out of here, so that's 2. That gives me y squared plus 2y plus something. So this will be a negative 2 plus something plus something. Half of negative 6 is a negative 3 squared, gives me a 9. So this is actually a 2 times 9 on this side. Half of 2 gives me 1. 1 squared is 1. So this is 2 times 1 on this side. So this becomes 2 times x minus 3 squared plus 2 times y plus 1 squared equals, it's 18 and 2, 18. And my circles have coefficients of 1, so I must divide everything here by 2. So I get x minus 3 squared plus y plus 1 squared equals 9. And there I have my circle. When I look at this equation, I see a 2y squared minus 8y minus 4x plus 10. I see only one square, so this must be a parabola. So my y's are already grouped together. 2y squared minus 8y. So on a parabola, it is something equals the square. So I'm going to have to move all of this to the other side. So that will give me a positive 4x and a negative 10. This is not a perfect square, so I'm going to have to divide out the 2, and I'd get y squared minus 4y plus something will equal 4x minus 10 plus something. Negative 4 divided by 2 is a negative 2, squared is a 4. So over here on this side, it was a 2 times 4. So this gives me 2 times y minus 2 squared equals 4x minus 2. All right. So our parabolas, this is an x equals y squared parabola. So I want this to just read x. So I must divide everything by 4. So this gives me 1/2 y minus 2 squared equals x minus 1/2. And there I have my parabola. Now can we write them from the standard conic form back into the expanded form? So this one is a parabola. And so parabolas are basically y equals x squared. So I'm going to multiply everything by 12. So this would give me 12y plus 48 equals, I'm going to square that x, which is x squared minus 4x plus 4. And I want everything, all my variables, everything on one side of the equal and set it equal to 0. So in expanded form, I must get my equation equal to 0. So I'm going to subtract the 12y and subtract the 48. So this gives me 0 equals x squared minus 4x minus 12y minus 44. And there I have my parabola. In expanded form. The next one looks like a circle, so I'm just going to have to square those. So this squared is x squared minus 4x plus 4 plus this squared is y squared plus 8y plus 4, excuse me, that's plus 16, equals 16. If you cannot square these in your head, then you're going to have to do x minus 2 times x minus 2. And in this one, you're going to have to do y plus 4 times y plus 4 to get these squares. Again, since I'm supposed to write it in expanded form, I must equal it to 0. So I'm going to have to subtract that 16. So I have x squared minus 4x plus 4 plus y squared plus 8y plus 16 minus the 16 equals 0. Well, 16 minus 16 is 0, so I'm going to put my x's first. X squared minus 4x plus y squared plus 8y, and then I have this plus 4 equals 0. And there I've changed it to expanded form. All right, this ellipse, I'm going to have to find the LCD. So the LCD between 4 and 25 is 100. So I'm going to have to multiply each equation by 100. Excuse me, each fraction by 100. So this one reduces to a 25. So I have 25 times, then I have to square this. So it is x squared minus 4x plus 4. Plus, this reduces to a 4. 4 times y minus 3 squared is y squared minus 6y plus 9. Should equal 1 times 100 is 100. So this is 25x squared minus 100x plus 100 plus 4y squared minus 24y plus 36. And since it's expanded form, I'm going to subtract the 100, so I get my 0. So I have 25x squared minus 100x plus 4y squared minus 24y. So this 100 minus 100 would be gone, and I'm left with the plus 36 equals 0. And then our last one. My LCD between 2 and 25 is 50. So I'm going to multiply each fraction by 50. So here it reduces to a 25. 25 times x minus 3 squared is x squared minus 6x plus 9. This reduces to a 2, so it is minus 2 times y plus squared plus 10y plus 25 equals 1 times 50 is 50. So this is 25x squared minus 150x plus 225 minus 2y squared minus 20y minus 50. I'm going to subtract this 50, so minus another 50 equals 0. So 25x squared minus 150x minus 2y squared minus 20y. So we've got 225 minus 100 is plus 125. And there I have my hyperbola in an expanded form. So expanded simply means multiply everything out. Standard means write it in its conic form. Right? So here I have one more where I'm going to have to find my LCD. So first, this is usually only one number under here, so I would have to multiply by 3. So I would have to multiply the denominator by 3, so I have to multiply this numerator by 3 just to simplify this into a conic that I am used to. So here that would reduce. So I would have 3 times y minus 3 squared over 5 minus x plus 2 squared over 4 equals 1. So my LCD is between 4 and 5, which would be 20. So I'm going to multiply every one of these fractions by 20. So this reduces to 4. 4 times 3 is 12 times y squared minus 6y plus 9. 20 and 4 reduce to 5, so it's a negative 5 times x squared plus 4x plus 4 equals 1 times 20 is 20. 12y squared minus 72y plus 108 minus 5x squared minus 20x minus 20, then subtract this 20 to get 0. So I have 12y squared minus 72y minus 5x squared minus 20x. 108 minus 40 is plus 68 equals 0.